let's go to page 217. This is lesson 4.1, and this lesson is to apply triangle sum properties. A triangle is a polygon with three sides. So you can see the word tri. Tri means three angles. So a shape with three angles would be the one with three sides. Okay? A triangle with vertices. Vertices are the corners. So vertices ABC is called triangle ABC, or the simple triangle ABC. So this is how you say it, and this is how you write it. Okay? Now, you can classify triangles first by the length of the sides. So scaling triangle would be all three sides, there's no congruent sides, so all three sides are different. Okay? Isosceles triangle, iso means same, so isosceles means same length. So when triangle have when you have two sides that are equal or congruent, that means they're isosceles. Okay? Or at least two sides. So equilateral triangle, equi means same, lateral means side. So equilateral means all the sides are equal. So equilateral triangle means all three sides are congruent. Okay? Now, notice it's at least two congruent sides. So that means this is part of, so if it's equilateral, that means it's also isosceles. Okay? It just has all three sides are congruent. So these are classified by the size. Now, the triangle can also be classified according to the angles. Right. So all three angles are acute. Acute means sharp. So think about like an object. If it's sharp, it can puncture. It can puncture. If you poke against yourself, it can puncture your skin. Right. So acute means sharp. So when all three angles are acute angle, this is acute triangle. Right triangle is when one of the angle is right angle. Okay, obtuse means blunt or not sharp. So like this over here. So when you have one obtuse angle, then that's obtuse triangle. Okay, now next one is equiangular triangle. Equi means equal, angular means angle, right? So equiangular means the angles are equal. So it means when you have all three angles are congruent. Okay. So again, you have three congruent angles. That's called equiangular triangle. Okay, so you have acute triangle, right triangle, obtuse triangle, and the equiangular triangle. Now, this is easy to remember. A lot of times students get confused between the two. Now, there's an easy way to remember. Think about the letter A. Notice the top is very pointy, it's sharp, right? So think about triangle is sharp. It can poke you, right? Whereas obtuse, notice it's kind of nice and smooth. So when you push against your body, it won't kind of puncture you, right? It won't cut you, right? So think about when the angle is really big, so it's not sharp. So you can think about the O is nice and smooth. Think about this is kind of corner, kind of sharp, and the letter A is kind of sharp on top. So that's how you kind of able to remember which is which. Okay. Okay. Now let's go to example 1. Example 1, classify triangles by sides and by angles. Okay, support beams. Classify the triangular shape of the support beam in a diagram by its sides and by measuring its angles. So what you do is you get a protractor. Okay, we're not going to do that, but okay, if you have a protractor, you can go and measure the angle, and also you can measure the length. Okay, so notice that this are congruent. See the little markings. Okay, so the triangle has a pair of congruent sides, so it's isosceles. Again, two sides are congruent, so that's isosceles. Okay, by measuring the angle, okay, the angles are 55, 55, and 70. So it's acute isosceles triangle. It's acute because all angles are less than 90. Okay, okay. Let's go to the next one. Okay, example 2, classify a triangle in a coordinate plane. Okay, so classify triangle PQO by its size. Then determine if triangles are right triangle. Okay, so we're not going to do that in detail, but you should know how to do that already. So coordinates. Okay, so first you have to find the length of each side. So OP, you use the the x2 minus x1 plus a square, then plus the y2 minus y1 square. So this is your distance formula. Okay, so if you don't remember, you have to go back and review it a little bit. And so this is equal to square root of 5. And so use a calculator, it's approximately 2.2. Okay. A quick way of doing it is when you have a graph, okay, it's quicker not to use the distance formula. It's quicker if you just go and use the Pythagorean theorem. Right? It's a squared plus b squared equal to c squared. So this is 1, so 1 squared is 1. This is 2, so 2 squared is 4. So 1 plus 4 equal to 5. And you take the square root, you get the square root of 5. See that? Okay? Now OQ is from here to here. Again, use your distance formula. You plug in the numbers. Right? So x2 minus x1. Right? So x2 minus x1, and you square that. And you have the y2 minus y1 square. And you get, and you get square root of 45. Or another quick way of doing it is use your Pythagorean theorem, count the squares. So you got 1, 2, 3, 4, 5, 6. So 6 squared is 36, and this is 1, 2, 3. So 3 squared is 9. So 36 plus 9 give you 45, and you take the square root, right? Because again, a squared plus b squared equals c squared. So you have to take the square root to get c, right? So again, 6 squared is 36. 3 squared is 9. So 36 plus 9 give you 45. And take the square root, you get square root of 45. Okay, so when you have graph, it's a lot quicker if you use a Pythagorean theorem. Now to find PQ, this one over here, okay, you can use your x2 minus x1, then you square that. y2 minus y1, you square that, and you add together, and that will give you square root of 50. Okay? Or if you use Pythagorean theorem, you count the square, right? So you got 1, 2, 3, 4, 5, 6, 7. So 7 squared give you 49. And over here it's 1. 1 squared give you 1. So 1 squared is 1. 7 squared is 49. So 1 plus 49 give you 50. Okay? And that's how you get square root of 50. Okay, so you found all three lengths. So all three lengths are different. Okay? So this is scaling, right? And now to find if it's a right triangle, you can use a squared plus b squared equal to c squared. That's one way of doing it. So if you a squared give you 5, b squared give you 45, c squared is equal to 50. So a squared plus b squared equal to c squared. So it checks out, then tells you that it's a right triangle. Another way to get a right triangle is by checking the slope. Okay. So the slope of this, remember slope is you start from here, go down, right? So the slope you can use the slope formula. So y2 minus y1 over x2 minus x1, right? Or when you have graph, it's not easy. You just follow the path. So from here to here, you go down 2, right? So go down 2. So negative 2 over 1. So the slope is negative 2. Okay. Over here from here to here, you have to go up 3. So 3 and 6. So 3 over 6 is 1/2. So this is negative 2. This is 1/2. See that? So negative 2 and this is 1/2. And because they are negative reciprocal, or if you multiply, you get negative 1. So again, all these are theorem that you know from before. Okay? So either way, you can prove that because the slope are negative reciprocal, therefore this is a right angle. So you can conclude that this triangle is a right scaling triangle. It's right triangle because there's a right angle right over here, and the scaling because all three sides have different lengths. Okay. So again, you have to know all those things. Okay. Okay. Angles. When the sides of a polygons are extended, okay, so you have triangle and you extend these, right? The other angles are formed. The original angles are the interior angle. So this original angle, this is interior angle, means the angle inside the triangle. Those are interior angles. The angle that form linear pair with the interior angles are exterior angles. So from here, so here's your interior angle. So the one that form linear pair would be either this one or this one. So these are called exterior angles. Okay? Exterior angles are the angle that form the linear pair with the interior angle. So this is not an exterior angle because these are vertical angles. Okay? So this is an exterior angle. These are exterior angles. Okay? So you can see the blue right over here. So again, interior angles are the angles inside the triangle. exterior angle are the one that form the linear pair. So like this one or this one. Okay, this one is not. This is a vertical angle. Okay, so over here the theorem. Okay, theorem 4.1, triangle sum theorem. The sum of the measure of the interior angles, the angles of a triangle is 180 degrees. So in other words, the angle A. Now, because there's only one angle, so you can use just a single letter, okay? If you have this kind of case, then you cannot just use, say, angle A, because there are different angles, okay? So when you have more than one possibility, you have to be more specific. But when you have only one angle, you can just use one letter. So over here, angle A, so measure angle A plus measure angle B plus measure angle C will equal to 180. So in other words, when you add the three angles together, it will always equal to 180 for the triangle. Okay, let's go to page 219, auxiliary lines. So it says to prove certain theorem, you may need to add a line, a segment, or a ray to give diagram. An auxiliary line is used in the proof of the triangle sum theorem. So auxiliary line means the line you have to draw yourself. You have to add lines and to do proofs. Okay, so like when you're giving a triangle, and what you do is you draw a parallel line to the bottom over here. See the blue marking right over here? It tells you that these are parallel lines. So this is called an auxiliary line, okay? Because it's not given to you. So you have a triangle, so you have to draw the line yourself, and the line you're going to draw is going to be parallel to the bottom, and you draw the little blue arrow over here to indicate that this line and the base are the parallel, okay? So here's a proof. So giving a triangle ABC, notice that's it, right? You want to prove that measure of angle 1 plus measure angle 2 plus measure angle 3 equal to 180. Okay? So first, you have to draw the auxiliary line through B and parallel to AC. So you draw the line through the vertex over here, and it's parallel to here. Okay? So that's your auxiliary line. Okay? And then B, you want to show that angle. So once you do that, you label the angles, right? So you start with angle 1, 2, 3. Once you draw the line, you make this angle 4 and 5. Okay? So first, you show that angle 4 plus measure angle 4 plus measure angle 2 plus measure angle 5 equal to 180. And the reason because this form a straight angle, right? So 4 plus 2 plus 5, this gives you form a straight angle, and straight angle is 180 degrees. Okay? Then after that, you try to substitute the different angle into that to make it equal to 180. Okay. So you want to show that angle 1 and angle 4 are congruent, right? These are alternate angles, and these are alternate interior angles. So you can substitute 4 and 1. So 4 becomes 1, and 5 becomes 3, and therefore you prove that. Okay. Okay. So that's kind of first you kind of think first, plan it out, then you can actually write it out. Okay, so over here, draw BD parallel to AC. So this is parallel postulate. Okay, you can always draw a parallel line through a point. Okay, and then after that, you got measure angle 4 plus measure angle 2 plus measure angle 5 equal to 180. So this is angle addition postulates. Okay, and definition of straight angles. Okay, then after that, you can have angle 1 is congruent to angle 4, angle 3 is congruent to angle 5. These are alternate interior angles theorem. Or you can just say alternate interior angles are congruent. Okay. Then after that, you can, because they're congruent, so the measurement would be same, right? You have equal measurement. So definition of congruent angles. Again, if angles are congruent, the measurement would be equal. Okay. Then after that, once you find that equal, you can substitute. You can replace angle 4, measure angle 4 with angle 1, right? So this becomes that, this becomes this, and this becomes this, okay? And that's it. So that's a substitution. Okay, so next one, the theorem 4.2, the exterior angle theorem. It says the measure of the exterior angle of a triangle is equal to sum of the measure of the two non-adjacent interior angles. So what it's saying is that the exterior angle will equal to sum of the other two angles. Okay, that is not adjacent to this angle. So again, so exterior angle equal the sum of the two remote angles. Okay, so from here, example 3, find the angle measure. So you want to find measure of angle JKM, you're looking for this angle. So from this theorem, we know that exterior angle equal the sum of the two remote angles. Okay, so again, the exterior angle equal the sum of the two other angles. And the reason for that, again, because the three angle equal to 180 and this equal to 180, therefore you just substitute. So these two will equal to that. Okay. But anyway, so write and solve equation to find the value of x. So first, you apply the exterior angle theorem. So this equal to this two, right? So 2x minus 5 equal to 70 plus x. So again, exterior angle equal to sum of the two remote angles. Then after that, you solve for x. Okay? So to solve that, again, you just minus x on both sides and you plus 5 on both sides. Okay, so do a little bit of algebra. So after that, you substitute 75 for x in here. So 75 here and 70. And therefore, when you add, you get 145 degrees. So JKM equal to 145 degrees. So again, from here, you're going to solve for x first. Once you solve for x, you can go and substitute. Okay. Now, notice instead of substitute over here, it's quicker if you just add these, right? Because this is equal to sum of these two. So once you find angle x equal to 75, you just use 75 plus 70. This would be quicker to get 145. Okay. That way you don't have to substitute and work out. Okay? Because again, this is equal to sum of these two. So if you add these two, you get that. Okay. So this is a longer way to do it. It's quicker if you just go and add these two together. Okay. Okay, on page 220, okay, a corollary to a theorem is a statement that can be proved easily using the theorem. The corollary below follows from the triangle sum theorem. So a corollary is a conclusion you can make from something that's already proven. Okay, so over here, corollary to the triangle sum theorem. It says the acute angles of a right triangles are complementary. So what it's saying is that the acute angle, so angle A and angle B are complementary, means they're equal to 90 degrees. Okay, and you can again, it's something, a conclusion you can make easily, right? Because think about it, right? For the right triangle, okay, remember the three angle is always 180, right? So if this is already take up 90, that means these two have to take up the other 90 degrees, right? Okay. So again, measure of angle A plus measure of angle B equal to 90 degrees, because the three angle equal to 180 and this is equal to 90, so the other two have to equal to 90. Okay. Okay, let's go to example 4. Find angle measures from a verbal description. Okay, so architecture. The tiled staircase shown forms a right triangle. So over here, see that form the right triangle. The measure of one acute angle in a triangle is twice the measure of the other. So this is twice the other. Okay, find the measure of each acute angle. Okay, so remember, a triangle equal to 180 degrees, right? So if this is 180 degrees and this is 90, that means this is equal to 90 degrees together, right? So see that? And because this is twice as that, so you just, when you don't know a number, you just assign a variable. Okay, so you can call this x, and because this is twice as that, so this will be 2x. So that means 2x plus 1x will equal to 90 degrees. So here, say 2x, so x plus 2x equal to 90 degrees. So you add together, so it'd be 3x equal to 90, and you divide by 3, so x equal to 30. So this would be 30, this would be 60, and this would be 90. Okay?